Welcome to the last video of the section, Face Detection and Tracking. In the previous video, we learned about optical flow-based tracking. In this video, we will see how to automatically detect the location of a face in a live video and track it. We will use Haar cascades for that. We will also track the eyes as a separate entity. Face detection refers to detecting the location of a face in a given image. This is often confused with face recognition, which is the process of identifying who the person is. A typical biometric system utilizes both face detection and face recognition to perform the task. It uses face detection to locate the face, and then uses face recognition to identify the person. Let's see how to build a face detector. Create a new Python file and import these packages. Load the Haar cascade file corresponding to face detection. The file is already provided in the code bundle. Also, check if the cascade file has been loaded properly or not. Initialize the video capture object and define the scaling factor with this line. Next, iterate indefinitely until the user presses the escape key. In this, we first capture the current frame. Then resize the frame. Next, we convert the image to grayscale. After that, we run the face detector on the grayscale image and iterate through the detected faces and draw rectangles around them. Finally, display the output. Check if the user pressed the escape key. If so, exit the loop. Once you exit the loop, make sure to release the video capture object and close all the windows properly. Run the code. Type python facedetector.py. My face is being detected here. Cool, huh? Our next step is eye detection and tracking. Eye detection works very similarly to face detection. Instead of using a face cascade file, we will use an eye cascade file. Create a new Python file and import these packages. Load the Haar cascade files corresponding to face and eye detection and check if the files are loaded correctly with this line. Initialize the video capture object and define the scaling factor. After that, iterate indefinitely until the user presses the escape key. Here we first capture the current frame. Then we resize the frame. Then we convert the frame from RGB to grayscale. Then we run the face detector. For each face detected, you need to run the eye detector within that region. And then you have to extract the region of interest and run the eye detector with these lines. Then draw a circle around the eyes and display the output. If the user presses the escape key, exit the loop. Once you exit the loop, make sure to release the video capture object and close all the windows. Run the command. You will get this window. You can see that my eyes are being detected. Looks like cool glasses. That brings us to the end of this section. In this section we learned about object detection and tracking. We understood how to install OpenCV with Python support on various operating systems. We learned about frame differencing and used it to detect the moving parts in a video. We discussed how to track human skin using color spaces. We talked about background subtraction and how it can be used to track objects in static scenes. We built an interactive object tracker using the CAM-SHIFT algorithm. We learned how to build an optical flow-based tracker. We discussed face detection techniques and understood the concepts of Haar cascades and integral images. We use this technique to build an eye detector and tracker. In the next section, we will discuss artificial neural networks and use those techniques to build an optical character recognition engine.